Well, hello and welcome, everyone. Thank you so much for coming to today's workshop. Today, we're going to be talking a little bit about building a decentralized sweepstakes and raffle. I'm really excited to be here. Uh, I want to start with a little bit of a story to set the tone for today's workshop. And so the story starts with my family over in Arizona, where basically every year when I'm there for the holidays, they play a game of bingo. So we have this little box that just sits on the table, and every time you press it, it plays out a new bingo number. And as you know, bingo is a game of chance, not really skill, right? Like people think there's a little bit of skill in terms of picking the cards, but generally it's going to be random chance to see whether or not you win. And we have all these like little prizes. It's like little pens and cookies and goldfish and all sorts of crazy like little prizes. But I know that that is a relatively fair way of distributing the prizes because I'm close enough to validate and verify the machine is working in the way. And because it's my family, there's maybe some things there that maybe I know these people, I know they're not going to be trying to cheat me. There's no malicious intent. These are not random people on the internet. But I want to contrast that for a moment with a different type of way that prizes were distributed. And so this goes way back to 1989 to 2001, which was a long period in time where McDonald's was running the McDonald's Monopoly game. And I loved this game. Like this was a very, very cool game because like you collect the pieces, you buy French fries, and you win another set of French fries. It was like a really fun game to participate in because I thought, oh, I can win these great prizes. But what has come out since then was that it was actually not a fair raffle. It was not a fair sweepstakes. It was not a fair way of giving away prizes as part of this system, as part of this marketing effort. So yeah, from 1989 to 2001, there were almost no legitimate winners. So the people that were running it and executing it were actually keeping all of the good prizes for themselves, which meant that there was no fairness, there was no transparency. And this is something that I really love about blockchain is because I think blockchain and these transparent dApps that we build can be a better way to come up with decentralized, fair ways of doing things and coordinating large groups of people. So that's a little bit of what we're doing today. So let's dive into a little bit about this. So if you think about it, when you think about a raffle or a sweepstakes, what we really want is that we want it to be decentralized. We want it to be something that is not manipulable by people coming in and saying, well, I'm just going to hold all the prizes to myself, right? You want it to be transparent. And this is what's so fantastic about using technologies like blockchain and Chainlink. And then the other nice thing is that unlike my family bingo game, you don't have to wait for the holidays. We can do it right now. So let's go ahead. If you don't know me, my name is Stephen Fluin. I am head of developer relations at Chainlink Labs, working on Chainlink. And this is the sort of stuff that gets me really, really excited, is helping you to build cool applications using cool new technologies and build things better. So as we go through today, there's going to be a lot of live coding. We're going to go through some concepts first, but then hopefully you're able to take these concepts and apply them into your own projects and actually build something and ship something to the web. So we're going to go through this in three parts. We've talked a little about the why we're building this, but I want to go into specifically what we're building so that we're all on the same page before we dive into an IDE. Then we're going to do a whole bunch of live coding. That's going to be the bulk of what we're going to cover today. And lastly, I want to talk about some additional considerations that you should have before you go to production with this sort of technology. All right, let's talk about what we're building today. So I mentioned that it's a sweepstakes and raffle, and as you saw in the title, but effectively, actually, what we want is we want to build a decentralized automated raffle. There's a bunch of different definitions for these terms, so I'll use raffle and sweepstakes relatively interchangeably here. But effectively, it's a system where anyone can enter for a fee. We are then going to have the system randomly and fairly pick a winner for a round from the entrants that have participated. And then we're going to pay the winner all of the fees. So there's not going to be any sort of consideration for the system. And then we want to automate this system so that we can run repeatedly as long as there are players. So again, this is not something that I'm going to be executing. I'm going to be behind the scenes clicking and choosing winners. We want this to be a system that works autonomously. We want this to be a system that works decentrally. So if you want to think a little bit for a moment about how a raffle works, you can think about it as maybe there's a prize pool. A bunch of people are going to enter in order to be part of that prize pool. So they're all going to send a little bit of tokens. And then that pool is going to randomly determine who should be the winner and then send all of the prizes back to that person. So relatively simple concept, but make sure you understand this before you try and dive into what we're actually doing with the code. And lots of great comments in the chat. So we've got let's go, beast mode, let's go. Let's do this. So effectively, I'm going to be using two Chainlink technologies here today that are really, really important to some of the things that we're doing. So the first is we're going to be using Chainlink's VRF, or verifiable random function. And we rely on it for several different reasons. We need a random number generator. We want something built on cryptographic truth that can do things in a fair way. Chainlink's VRF uses kind of a commit reveal scheme where effectively, because you're separating a random number generation into several blocks, there's no way for someone to extract value or manipulate that number by choosing not to include something in a separate block. And this is also tamper proof. So if anything happens along the way, you can actually see it, which is one of the best things about Chainlink's VRF. The other technology we're going to be using today is Chainlink Keepers. So we've heard during this hackathon about several of the amazing capabilities of keepers, and I'm going to be showing off how to use those with Chainlink's VRF. So automation is a big deal here. So like having a timer that's running and automatically closing and distributing prizes, those sorts of things. But one of the things I love most about Chainlink is actually this off-chain compute, where if you're doing some sort of expensive operation on chain, you can actually take a lot of that pre-computation and put that into a keeper and have that run off the blockchain for far cheaper, and then just put and verify the results on chain as part of that. And so we're going to be showing this as a fully integrated example that's using kind of these multiple technologies all combined. All right, I think that's going to be it for the preamble. So let's dive into the live coding. There's lots of great tools that you could be using at home in order to follow along. If you take a look on our GitHub, we've got a Chainlink Hard Hat starter kit. We've got a Chainlink Brownie starter kit. These are great ways if you're thinking about developing this into a more full project. But in order to skip some of the complexities of building locally, I'm just going to be using Remix. And so you can definitely use Remix to do this. So let's go ahead and talk about the plan. So I'm going to do this in 3 stages. First, we're going to just build a simple raffle with no randomness and no automation, just to make sure that we've got a principle that works. And then I'm going to dive in and add in VRF so that we can randomize the winner selection. And finally, we'll add keepers. So this is an automated process that we don't have any manual involvement in. So let's go. So I'm going to close the presentation here, and we're going to dive into Remix. So I want everyone to be able to follow along. So we're literally going to be jumping into a blank, brand new Remix workspace. And so the first thing I'm going to do is I'm going to create a brand new file, and let's call this raffle.sol. No such file. Okay, great. That file didn't exist because we hadn't created it yet. So again, as I go, I'm going to be explaining everything, but effectively, I think Remix is having a little bit of a hiccup here. So let's refresh. And I will be answering questions as we go if any questions come up here. So let's just switch. Yeah, this workspace is borked, it appears. So let's just go ahead and create a brand new workspace. Woohoo! Let's just create a new raffle.sol contract. Let's go ahead and delete these other contracts. We do not need them. All right, brand new SOLIDITY workspace in Remix. If you haven't been there before, remix.ethereum.org. It's a fantastic web-based IDE. It's going to really show us what's actually happening under the behind the scenes with a lot of these contract principles. So SOLIDITY, and then we're going to say we're going to be in version 8. And let's go. So we're going to start off defining our contract. So this is just going to be a very simple raffle. And again, I walked through the principles of kind of what we're building here. And so we're going to need a few kind of just state variables that we're going to use throughout the application. So we're going to have a uint256. And I'm going to underscore a bunch of the storage variables with the idea that these maybe could change. And so we want them in storage. And we'll just underscore with S so that we recognize that that's what type they are. And we're going to say entrance fee. We're going to just say 10 gwei. Let's keep this very, very cheap, very, very simple in case we need to do lots and lots of tests. Obviously, you can set this to be whatever you want in your application. And then in order to kind of share this with the world, let's imagine we're building a friend later. Let's actually store the recent winner so that we can share that out to the world. People can build cool web UXs that say, hey, you won, you didn't win, those sorts of things. And then the key here is going to be a payable list of players. So this is all the array where we're going to be storing everyone that is playing in the current Raffle. Okay. And I'm going to need two functions. So I'm going to need a function for enter Raffle. It's going to be payable because you're going to need to pay to enter. And I'm going to need a function called choose winner. Just get rid of all this extra stuff so that everyone can see a little bit better. Hopefully that works well for everyone. Chat. Hello, hello. All right. So we've got this basic contract with the overall structure set up. So the first thing we want to do is let's make sure that when they enter the raffle, they're actually sending the fee that we've asked for. So let's go ahead and require the value of the current message to equal the entrance fee. And if they don't, we'll tell them, please send 10 Gwei. And then what we'll do is if they've done that, if they've passed the require statement, then we will just take the players array and we will push them in as a new payable. All right. So that's basically it for the entrance side because we're not going to limit how many people can play. Just if you send 10 Gwei, we're going to add you to the players array, and that's it. Theoretically, there could be some edge cases you might want to check here. What if you're expanding the number, passing the number of players that are available in a UINT 256? Not going to happen, but just think about what happens at scale with your application. And now for the choose winner part. So because we don't have randomness yet, just because we're kind of starting here, I'm going to decide that the random winner is going to be player 0. So again, this is not yet a fair raffle. This is not a decentralized raffle. This is me just saying whoever enters first is going to be the winner. And what we'll do is we'll say that this is going to be an address payable for that winner. And that winner is going to be the player with the index of our random winner. Again, just setting up the raffle here. And we'll save the recent winner so that anyone can see that. We can build great UXs. And then what we're going to do is we're going to actually send some tokens to that person. So I'm going to say winner.call, and we will send them the value of whatever this contract. So again, we're not taking any sort of consideration here. It's just pay in, pay out. And we want to verify that we've been successful here before we actually do anything with that. So we're going to require success. And if for some reason this wasn't successful, I can't think of a case where this might fail because we're transferring exactly the balance that we have. But you could say transfer to winner failed. All right. And then I think the final thing I need to do is I want to clean up the round for the next, or clean up the players for the next round. So I'm just going to delete S players, which will set it back to an empty array. When I'm working in Remix, I really love the capabilities of what it shows you on the left side, right? You can really dig in and see any of the public variables. You can call it methods, and that's part of why I'm using Remix today to show off all these sort of things. But one of the things you can do is you can build yourself a little status method. And so what I'm going to do is I'm going to make this just a public view method that gives us a couple numbers, 256, and another UINT 256. And what this is going to do is this is going to allow us to actually do a little bit of reporting. So in this case, what I want to do is I want to return two things. I'm going to return the balance of this contract, so we don't have to check it somewhere else. And then I'm also going to return the number of players. So just help demonstrate as we're building up the raffle and then as we're using it, all these things that are happening. So with that, I think we've actually completed stage 1. And so we have a raffle that works now. And so what we can do is we can make sure it's compiling here. Again, we're using the latest version of Solidity. We've got auto compile on, so it should tell us if there's any warnings, which we got a couple warnings, but no errors, which is perfect. And now I'm actually going to do a little test here where I'm going to deploy it using the virtual machine that exists within Remix. So we're going to make sure that we've got our contract selected, and I'm going to hit deploy. And what Remix gives you is a bunch of different accounts, so we can actually go ahead and try and enter this raffle a couple times. So let's go ahead and enter this raffle. So let's make sure that we're sending 10 Gwei, and we'll hit enter raffle. So if we pull this up, we can see that transaction's gone through. And if we look at our little status object, we now have 10 Gwei in the balance of this contract, and we've got 1 player. And so what we could do is theoretically we could switch to another account. We could send another 10 Gwei to that contract. Again, I'm just using this Remix interface that uses the ABI to allow you to kind of very easily hook into the right transactions. And it looks like I did not 10 right. Hit Enter raffle. Okay, so we've entered the raffle with 2 accounts. We should have 2 players and 20 gwei effectively. And so now what we should be able to do is call the choose winner method, which executed. We should have sent back some of the funds. Yep, it looks like we sent back both of the entirety of the funds, and our status should be reset. So now we've got no balance left and no players. So we're ready for another round here. So that was step 1. Now we have a working raffle, and that raffle doesn't randomly choose a winner, but theoretically, you can see very easily how we could tap in and actually put in a random number generator here. So I want to talk a little bit about random number generators, because if you naively just use, for example, the block number here, that's actually manipulable. There's something called miner extractable value, where, for example, one of the miners or someone on the blockchain could actually run this transaction, like see it in the mempool as a transaction that's going to run, right? Someone's choosing the winner, and they could actually say, based on the hash of my block, am I the winner? And if I'm not, let me just drop it. And someone else will do it, and I'll still have the same random chance, but it gives me an extra chance every time I do this. And so that's one of the reasons that you can't just rely on randomness generated from the kind of procedural methods that exist within the blockchain. This is where an oracle, such as the Chainlink's VRF oracle, can be super, super helpful. And so what we're going to do next is we're going to take this code and we're going to make a couple changes to it that allow us to take advantage of Chainlink VRF. So let's go ahead and start diving into that. So we're going to want to do a bunch of different things. So one of the things that needs to change is because we've got that kind of commit reveal style scheme, we can't just do this all in one transaction. We can't do this all in one block. We don't actually want it to go in one block, because any randomness that lives in a single block, by definition, could be manipulable by a miner. And so what we're going to do is we're going to create a couple states. So we'll just say enum state. And what we'll say is that the enum state is going to allow open or calculating. I'm going to typo that a whole bunch of times. Please let me know if I do, just to help me out a little bit. And then what we'll do is we'll actually go ahead and save this. So we'll say state public s state, raffle state, and we'll just call it s state. Keep it simple. And what we'll do is it will be open by default, because that's the 0 index of the enum. And then we will go ahead and make sure that when we enter the raffle, we're going to actually require it to be open. So we'll require state to be equal to state.open. It's not, is currently closed. And then we'll go ahead and in our choose winner, what we'll do is we'll actually create a new method that opens the state. So we'll say close round. And so this new function is going to mark that the round is closed by doing state equals state.calculating. And then as soon as we've chosen a winner, what we're going to do is we're going to set that back. So we're going to say state equals state.open. So as soon as we've reset everything, then we know we are good to go back to the original state as part of our kind of cleanup here. All right, so we've got our close round method where we're calculating it, and then we're only allowing you to do it if we're not currently calculating. So effectively, there will be a gap here between when you call close round and when a winner is chosen, which is exactly what we want. All right, so the next thing we're going to do is there's a little bit of setup for VRF. So obviously, VRF lives on the blockchain at a coordinator address, and we'll want to configure our contract in order to access that. And so I'm going to create a bunch of different variables. So we're going to need access to the link token. You're going to need access to the VRF coordinator. You're going to need something called a key hash, which is effectively a public key for the coordinator, so that we can make sure that the transaction is secure. And I'm going to then want to make sure that I'm sending the right amount of Chainlink fee. So we'll just make a Chainlink fee variable. And then what we're going to do is, in order to figure out the value for all these things, it's actually pretty simple. You can just pull up the Chainlink docs. And what will happen is, depending on the chain that you're targeting, you'll give different values here. Oh, put it full screen. Thank you so much for the reminder. All right. So again, what we've done is we've added state variables here. And then we've started to configure VRF. And what we'll do is we'll just jump over the docs. I'll scroll down to VRF and we'll click on contract addresses. So what contract addresses will do is I'll be able to just find the testnet or the chain that I'm targeting. Here we're targeting Coven, and I will just kind of copy these one by one. So we've got link, VRF coordinator. We've got that public key for the Oracle. And then our fee here, it says it's 0.1 link. So the way you encode 0.1 link is you say 0.1 times 10 to the 18th power. We can just comment this is 0.1 link. All right, now that we've got the configuration variables that we actually need, let's actually go ahead and implement the interface that will allow us, or actually implement the contract, extend the contract that will allow us to actually use Chainlink's VRF. So what I'm going to do is I'm going to give you a brand new import. And so that import is going to be the VRF consumer base. So I'm going to say import from Chainlink / contracts source. We're using a v08. This contract is available in a bunch of different SOLIDITY versions. And then we've got VRF consumer base.sol. And if we've done things right, we should see that our contract is no longer valid because we're not actually overriding the methods that we need to be overriding. And so the first method that we need to override is actually the constructor. So there's lots of different ways to do this, but what I'm going to do is I'm going to extend the constructor here by calling VRF consumer base, and we'll pass it the VRF coordinator, and we will pass it the link token. So that's what the constructor of a VRF consumer base requires. And we've got an error here. So let's actually go to the compiler and make sure that we've pulled in our Raffle interface or our Raffle contract correctly here. So we've got Chainlink contracts source v08 VRF consumer base.sol. And that should be good here. Let's just check the syntax on my contract constructor, VRF consumer base. All right, I think that's great. So I'm just going to keep moving on, and then we'll come back to that in a sec and fix up all the errors. So in order to actually do this, in order to actually have a randomness feature, I'm going to need a fulfill randomness method. And the nice thing here is I can actually just modify our choose winner method here. So we're going to just replace choose winner with fulfill randomness. And the trigger that is going to say who has won and actually distribute the funds. Now, instead of me calling choose winner or whatever, it's going to be the randomness coming back from VRF that chooses the winner. And so just to match the API, we're going to say this is an internal override. And then fulfill randomness takes two parameters. We're going to take a bytes32. See, we're not actually going to be using in this specific use case because we should not have multiple raffles going on the same time, so we don't need to match up requests. So with bytes32, that's just the request ID. And then we should have a uint 256 called randomness. And actually hooking this into our method should be really, really easy, which means that we should just actually be able to take that randomness and do mod with the player's length. So effectively what we've done is we've taken this big giant random number and we've said we only need a random number of the size of the length of the players. So let's go ahead and recompile here and make sure that we've fixed this function override. Yeah, I think we've done something wrong with our import here. I'm just going to copy and paste the contract here. So it looks like we're pulling that in correctly. Constructor. If anyone sees what I've done wrong, feel free to call it out. So missing is VRF consumer base. That's possible. We got the links here. This all should be good here. Let's just try one more thing to give this a test. You're right. I'm missing the extends method. Sorry about that. Is inheritance and SOLIDITY. Thank you so much. Perfect. All right. So now that we've said that our Raffle actually is a VRF consumer base, then we've implemented the constructor appropriately. We've implemented the fulfill randomness, overriding that method provided by VRF consumer base. We now should actually have a contract that is capable of receiving a random number. So in order to test this, let's go ahead and make sure that when we close the Raffle, that's when we're requesting a random number. And so when we go into our close round, let's go ahead and do two things. Let's require that we actually have the right amount of link. So let's make sure that we have link in the amount greater than or equal to the Chainlink fee. And if you don't, we can say not enough link. And then if we do have enough link to close the round, then let's go ahead and request randomness. We're going to pass in the hash, pass in the fee that we're sending. All right, so with this, every time you click close round, we should actually be triggering that off to the Oracle, to the VRF node, and then that will come back to us by the fulfill randomness in this randomness parameter, and then we will actually set the winner based on that. So previously we were doing testing in the local VM. We can no longer do that because in Remix, there is no VRF coordinator. There's no VRF node operating in my local environment. So what we're going to do is we're actually going to switch over into Kovan. So we'll just go up here to the top. And now instead of saying JavaScript VM London, I'm going to switch to Injected Web 3 provider. And in MetaMask, I've already selected Kovan. And so we should actually now be able to deploy our Raffle. All right, and because this is actually happening on a real testnet, I'm actually going to have to send them a little bit of ETH. And this is going to happen a lot. So basically all the remix messages, I'm just going to say, yes, that looks great. And so we now have our Raffle deployed on the Kovan network. So in order to test this again, we're going to need to enter. So I'll just enter a couple times. And what I'm going to do is I'm just going to enter as myself so I don't have to be switching accounts. But we've picked Tengway. We should be able to enter the Raffle. Oh, sometimes you'll see this. When you scroll, if I scroll past this window, it changes the number. And so if I mess it up, again, feel free to call it out. Thank you, everyone in the comments. So we've got Tengway. Let's try scrolling properly this time. Enter Raffle. We're going to send the Tengway to the contract. And if we take a look at the status, as soon as that confirms, which went really fast, we now have one player. We now have a contract with Tengway. And we can actually just enter again as ourselves. There's nothing saying you can't enter multiple times in this contract. Which is an option of what you could do if you wanted. So we're going to enter Raffle again. We're going to see that we should have two players as soon as that transaction confirms. There we go. We now have two players. And now we should be able to close the round. But remember, in order to close the round, we actually need link because you need to send the Oracle a little bit of link in exchange for its services. So let's go ahead and do that real quick. So I'm going to copy the address of this contract, and we're going to send. Just do one link for now. So we'll just send one link to my contract. That all looks good to me. And as soon as that confirms, we should be able to close the round, which then will trigger off a request to Chainlink's VRF, which will then come back to us, fulfill the randomness, and we will have a winner. All right, so let's go ahead and close the round. So again, that is a paid transaction. And as soon as that is confirmed, we're not going to see any change to status. But what we are going to see is as soon as that VRF node returns back, it's going to actually do all of the work here. And so one of the things we can do is we can take a look at this on the Explorer. Let's just pull up that contract. And we should see a few different things. So we're going to see here the contract creation. We're going to see the two entries that we made. So again, we entered with Tengway, I think it was. And then what we see is this is our call to closing. So one of the things, if you're ever debugging contracts with VRF, the VRF callback is not actually going to happen in transactions. It's going to happen in internal transactions. And so you can see two of them here. But as soon as the VRF node responds, we're going to see a couple more show up here. So, and there we go. We just refreshed. Perfect timing. We can see the VRF node has now come back and actually distributed all that 20 GUI out to the randomly selected contract. And if we take a look at status, and this might just take a second for, there it goes. So now it's updated. Our raffle's been paid out, and now we're actually ready to start again. So we now have a raffle. We now have a decentralized, fair, provably random raffle. But I think that that's not enough. I want to take this one step further and add in automation so that it's not individuals that are calling this closed round and funding with link. I want it to be a system where I fund it with a bunch of link up front, and then the system's just going to keep going. It's just going to keep running these raffles over and over and over again. And so in order to do that, we're going to hook it up into keepers. So if you've never worked with keepers before, it's really, really simple. It's just basically two methods that you need to override. And so what we're going to do here is we're going to do another import from @Chainlink tracks source v08. And this time it's not actually, we're not extending it. It's going to be an interface. And we're going to say keeper compatible interface.sol. And hopefully I've done this one right. And let's not forget to add it here as the specific types. All right, perfect. That's much better. Far fewer errors this time so far. And now in keepers, there's two methods you need to implement. There is a method called check data, which effectively what that is it's allowing you to, check upkeep, which is the off-chain portion. So this is really, really nice where we can say function check data. It's got a very, very simple signature where it's going to take a optional check data. So effectively, when you set up your upkeep, you can say, hey, I'm going to send in some extra data. We're not actually using that here. Capitalization. This is going to be a public view, and we're going to override what's coming from the interface. And we're going to return something. We're going to return two things. The first thing is something called upkeep needed, which is a bool upkeep needed. So this is the indicator that you're going to give as to whether or not upkeep actually needs to be performed on-chain. Again, check data is this magical method that is run off-chain. It's simulated on the blockchain effectively. So you can do almost anything you could do in a live transaction except modify state. But then you can do pre-calculations and you can pass that into the actual thing. And so the other thing is we're going to do is we're going to do perform data. All right, so we've got our check data method. Now, check data, again, is how we're checking to see whether or not we need to actually run a round. We need to actually close the round. And so I'm going to create a bunch of Boolean variables here and then and them to do all the different checks that we want to make sure so that we can do all these checks offline and we're not spending much of gas to check these all the time. So first thing I'm going to do is I'm going to create a bool called hasLink. We're just going to copy and paste the link check that we have here to make sure that we're not checking or trying to do anything on chain if we don't even have the link. The next thing we're going to do is we're going to make sure that it is open. We're going to set that just to the state of the Raffle. Make sure you get the capitalization right. Make sure you use double equals, otherwise it won't be a comparison. We're also going to make a bool for upkeep needed. So one of the things that I want to do is I want this round to close every period of time. So effectively what this will do is instead of running the round every block, maybe I'll run the round every hour, or every 10 minutes, or whatever period of time I want to run this Raffle. And so in order to do this, I want to compare the current block.timestamp. Excuse me, it's just block.timestamp. And then we're going to subtract out whenever we did the last upkeep. So this is not something we have yet. We're going to have to create this in a sec. So we're going to save that with the last upkeep. And so let's go ahead and create that. So this will just be a event 256, click S last upkeep. And what we can do is we can compare that to in our check data here. We can say, has the amount of time since the last upkeep been more than, let's say, 1 hour? So this is one of my favorite things about Solidity is that if you do things right, you can just use these kind of very easy to use words. So bool upkeep needed equals block expected semicolon. No, that looks right. We're subtracting out this, and one other thing we'll need to do is we'll need to make sure that when we actually close a round, we set this equal to block.timestamp. Perfect. Now let's just debug this one last error. It's not one. Sorry. In all my other practice attempts, I did 2 hours. Hour is not a keyword. It's not a valid keyword. It's 1 hours. Sorry about that. All right, perfect. And we do have a compilation error. So let's, we've mislabeled the keeper compatible interface. So let's go ahead. One of the best ways you can actually do is you can check this on unpackage if you've never used that before. You can actually, it's a way to explore NPM packages. So we can just say source 08 interfaces keeper compatible interface. So let's just copy and paste the full correct path. should fix our compilation error. Perfect. We've got a shadow declaration. Don't actually care about that warning. Data location must be memory or call data. All right, let's fix that. So we've got here check data is taking a bytes check data, which should be fine. Here we go. It's in our perform data. This needs to be memory. Should be it. Oh, this is supposed to be called check upkeep. Sorry. All right. We've gotten rid of the shadowing, which actually was a problem. We've now checked the upkeep here. And let's check in with the chat, see how we're doing here. So contract raffle is here of consumer base. Yep. Thank you so much for that. Can you put in a function that makes the raffle have a specific duration and the participation closes when the deadline arrives? Absolutely. So that question is absolutely what we're doing here via this upkeep needed. Actually, it is time. Let's just call that because we don't want to conflict with the variable we're setting here. So by checking the timestamp, we're going to make sure that the raffle has this duration. So if you wanted to do this fully in a real application, you'd also want to check this is it time in the perform upkeep or the close round method, as we've got it called right now, because anyone could call this method right now, and it would just bypass all these checks, or it would bypass basically this check. Great question. 7 minutes behind, but I got the raffle contract deployed. First checkpoint. Woohoo! Congratulations, Tippy. All right, so let's go back to our contract. So now, again, this is the first half of the keepers implementation. We've created a check upkeep method that we haven't actually finished. There was one other check that I wanted to do, which was I wanted to make sure that we have enough players. So let's bool enough players. And here we're just going to check, is the length of the players array greater than 1, right? I only want to actually run this if there's 2 or more players. Otherwise, we'll just keep the raffle open. And as soon as there's 2 players, then we'll go ahead and execute it. And then so what we're going to do is we're going to just set the return state here by saying upkeep needed equals has link and is open and is time and enough players. So one of the nice things is you can actually call this method yourself. So when we deploy it, well, we can make sure. And we've got an error here. Contract raffle should be marked as abstract because I'm not because I haven't finished implementing the interface. We'll fix that in just a second. So we have this method called close round, which actually corresponds really, really well to the second half of our keepers interface, which is we want to have a check upkeep method that happens off chain, and then we want to have a perform upkeep method that happens on chain. So what we'll do is we'll go ahead and just change the name of close round and change the signature to be perform upkeep. So we'll actually change it to match. And so this is very similarly to the check data on check upkeep. It's going to take a perform data. We're not going to use it, so we're just going to say perform data. Comments here. And then it needs to, instead of be public, it's going to be an external override. So external override, we should now be implementing the interface. And we can just, we're not actually using the check data in either use case, so we can just comment both of those out. All right, so what's going to happen now is once we register our contract with the Keeper network, it will be running this check upkeep all the time offline to make sure that we actually need upkeep to be performed. And if all those things pass, all those things are true, it will initiate a perform upkeep, which will set our state to calculating, check that we have enough link, and then actually request randomness. When we get the randomness callback, it will fulfill. And then I think we should be good. Let me just... let's actually just give this a try. So let's go ahead and again do this kind of manually first, and then we'll go in and do it dynamically. So unused function parameter, perform data. That shouldn't be a problem. Are we compiling here? Bytes upkeep needed. bytes memory here. Let's clean up this code so we can see it a little bit better. Bytes memory perform data. Call data check data. Remove function. It says it's just a warning. Yeah, let's try and proceed without this. I think this is a remix bug because that's a warning, not an error, which is just fine. All right, so again, we're going to want to clear out our old contract here. Let's go ahead and use the COVID network and deploy our contract. So click on Raffle here. All right, we've deployed our contract. So we should actually be able to enter the Raffle. If we throw in 10 Gwei, we should be able to enter the Raffle because that doesn't use any keepers or any VRF. Enter Raffle, and we'll do this 2 times. And as soon as that's confirmed, we'll go ahead and do it again, just to make sure. Great. And so we'll put this back up to 10, and we will enter the Raffle again. Great, that's been confirmed as well. Now, in order to get randomness, we're going to want to send it some link here. So we'll just send our contract some link, copy that address, send, paste. I'm going to choose one link. And the price for each random number is 0.1 link here on the testnet. And as soon as that's confirmed, we should actually be able to see what is happening here. So if we run check upkeep, it is true, which means that we've passed all of these parameters. We have link, the contract is open, it's time, and we've got enough players. So let's go ahead and fake a performance. So we can actually just pass in an empty bytes array since we're not using the data there anyway. We'll run this transaction. And what we should see is that that will kick off the randomness request. And as soon as that randomness request comes back from the VRF node, status will update and we should be good to go. But while we're waiting for that, I'm actually going to go ahead and switch over and actually register this contract on the Keeper network. So let's jump over to this. So URL for this is keepers.chain.link, really pretty easy to remember. And what we'll do is we'll register a new upkeep. So I'm just going to enter something here. We'll give this the upkeep name of Raffle, and we'll just call it 01 in case we need to do a bunch of these. We'll paste the address of our contract. Should match here. So we can pull this up in Dolphin Explorer here. Great. Everything's good. We've got our creation. We've got the fake upkeep that we did to kick off the randomness. We've got the 2 entrances. And then what we should see is that we can now register this. For gas limit, I'm going to say 200,000. The gas amount that Perform Upkeep uses in this contract is something like 150,000, but I'll just call it 200,000 here. We're not using any check data, and I will pre-fund it with like 20 link because what happens is the Keeper network calculates how much link it thinks you're going to need, and then says that over a period of time, and then says you need to have at least that much in order to run things on the Keeper network. So we'll confirm sending that link and performing this transaction. There's a lively discussion of decentralization of DNS on the chat. There are decentralized DNS style solutions out there, which we can chat about a little bit later, but we're going to view the upkeep. And so effectively, if you remember what we just did, we manually kicked off a perform upkeep on this contract, which actually concluded the raffle. And then we registered upkeep on this contract. So even though it's been funded and registered, it shouldn't actually execute, because if we go back to our contract and check out the status, it is not ready. And we can see this again if we run check upkeep manually, it's going to be false. And it's primarily false because we need some new entrants. So we need some new entrants, and we would need to wait 1 hour since the last upkeep. This should be the current timestamp. But now, effectively, if you enter this raffle, let's just do that real quick, and then I'll tell you what you're going to see in 1 hour from now. We'll enter 10 again, and we will, as soon as that confirms, we'll be able to enter 10 again, and raffle one more time. And if we look at the contract, we're going to see the same thing. We're going to see 2 new entrants. Oh, those are not the entrants. Block Explorer to actually update here. We should see it in our contract status, though. Yep. So we've got 20 Gwei here, 2 entrants. And if we wait long enough, that will probably show up. There it is. You can see the two entrants. And if we keep watching and we keep waiting an hour until check upkeep is actually true, we'll see that the keeper will be running that perform upkeep method instead of us. So again, check upkeep is going to be false because our timer has not expired. We set a 1 hour timer. And so anyone that wants to enter this raffle, this sweepstakes in the next hour, has an equal chance of winning using Chainlink's VRF. And then it will automatically be closed in an hour based on our keeper automation. So that was actually the core of what we're building today. I'm just double checking my notes to see if there's anything else we wanted to build into this contract. I don't think there is. I'll just walk through one more time. So we've got enter raffle. That's anyone can come along and be part of the raffle. We've got the keeper checking to see when we should be closing the raffle. As soon as we do want to close it, we trigger a randomness request to figure out who should actually win this raffle. And then as soon as that comes back from Chainlink VRF, we are setting that random winner, paying them out, and announcing to the world that that is what happened. Perfect. All right. So debrief. We built a simple raffle. We added VRF for fair winner selection. And then we automated this with keepers. So we did a lot. This was success. But there are some other things that you should be considering when you're building a smart contract like this, when you're building a system like this. So I will say we are missing a whole bunch of different features. And I'm going to kind of go a little bit into depth into each of these. So the first thing you should know is that, for example, let's imagine that we were done with this raffle, right? We're done. We don't need it anymore. We actually put Link into the contract in a couple different places. So you can remember we funded this contract with Link by sending it, send it some link. But that link is now just sitting in the contract unused. In order to do this in the real world, in order to prevent us from losing all of that link in case we don't want to use this contract anymore, is we should have created a withdrawal method. So like allow yourself, turn this into an ownable and allow the creator to withdraw that link. So this would be a very, very good idea. So that link's not just locked up in the contract. And if you remember, we also sent some link over the keeper network. You can actually cancel an upkeep and then withdraw all the link from that upkeep. So you can get all of that link back from the keeper contract that was not spent as part of the setup or the upkeep. So this is pretty good, which is wonderful. You can get all of that back. That is a best practice. Make sure that you're not losing all of your link if you're doing this in a real environment. The other thing that we should be thinking about is what if a user wants to back out? So this is an optional thing. You don't necessarily have to do this, but what if someone enters the raffle and they say, oh, I don't want to play anymore. Like this is taking too long to find another player. I don't want that money to sit there. You should probably have a cancel or leave raffle method so that a user that wants to pull out and doesn't want to be part of it anymore is able to, again, get that GUI back that they put in. They won't be able to get back the transaction fees, but they should be able to get back whatever fee that you asked for. And then you should update the players array accordingly so they're pulled out and they don't accidentally win something. Error handling. You should probably think a little bit about ways that this can go wrong. So if you remember, we had a few require statements in here. So for example, we have a require here that the transfer succeeded. So think about what could cause that transfer to fail and what you should do about it. Another example is if we perform upkeep and there's not enough link, that's going to fail. And so this is actually a more interesting problem to solve for you in terms of error handling, because it's not just your contract. You've got keepers that's executing check upkeep. You've got keepers that's performing the upkeep. And then you've got this randomness coming back. And so, for example, what happens if your randomness comes back and something fails? Like, do you have enough data about the state to reconstruct that and then do some sort of manual intervention to fix the situation? So let's imagine you didn't have enough link or some other condition caused this to fail. What are you going to do to fix that so that to keep your users whole? Because VRF is going to provide randomness. It's not going to provide error-proof your code. Next example here is going to be local development. So everything I just did, I did in Remix, which is really, really great for beginners. It's really, really great when you're getting started with smart contract development because and it's so easy to demonstrate what's going on because in this deploy, you can deploy to real networks, you can switch networks, you can actually call all these methods. It gives you a little UI that allows you to actually show off all these things, right? Enter raffle, perform upkeep. You could build a custom UI for this, but that's kind of out of the scope of this talk. But if you're doing this for real, you probably want some reusability so that you can do testing and things like that. And so one of the things you should do is you should consider local development. I called out at the top of the event that we have both a hard hat starter kit as well as a Brownie starter kit. So if you're more comfortable in Python, more comfortable in JavaScript, TypeScript, there are tools that will allow you to write the same contract in a way that can be deployed locally. But the thing you need to know if you're going to be deploying locally is that you actually can't just test this natively, because if you just look at the Ganache or the Hard Hat network by default, they have no keepers, they have no VRF coordinator, they have no VRF node. And so effectively what you do in order to test these things is that you mock out those parts of your code. So anytime that you're calling out to request randomness, you need to mock that out so that you're giving back a random number, some sort of random number on your local network, and not waiting for another node to actually go and trigger your contract to wake up and do these sorts of things. So there's a little tiny bit of an uncanny valley with local development. So I definitely recommend, if you are doing local development, which we do recommend, also test it on a test set. Make sure you're deploying to Cove, and make sure you're deploying to Rinkeby and actually trying some of these things out. Yeah, the last thing is deploy. So as you can see, there's a fair amount of manual work for me to every time I want to show this, right? Like I had to deploy, I had to fund it, I had to enter the raffle, and then I had to check the status. You can do all of that fully automated by just writing a simple TypeScript deploy script using our Hard Hat starter kit, for example. And so it's relatively straightforward, but you just have to think about this coding as code instead of a human interaction where you're clicking boxes in Remix. Remix is not a great place for long-term development, because if my browser state gets lost, this contract is just gone, right? Like being on GitHub is a far superior way of building contracts. What else should you be thinking about? Front end. So we didn't actually get into building any sort of front end here, but as you can see, it would be relatively easy to get the ABI out of this contract, right? We could just copy the ABI, and then in some sort of front end, we could create a great interface that exposes like the connect to wallet button, the enter raffle button, and then you can be rendering out that status to the screen as some sort of cool interface, and you can animate all the transitions. Like this type of application, if you're going to go to production, you should be building a front end, right? A lot of smart contract developers assume everyone can just take an API and interact with their contracts, but most users care about a great experience in terms of interacting with the blockchain. So that was all the additional considerations that I wanted to give. One huge shout out to Patrick. He actually wrote a version of this workshop using Hard Hat. So if you just take a look at github.com/PatrickAlphaC decentralized raffle, you will see a very similar version, not exactly identical version of this raffle, where it's actually built in Hard Hat. It's got a couple tests. It's got a deployment script. It can automatically fund Link. It'll set up all the mocks, all those sorts of things. All of those we have a really, really great example of in this repo. So definitely check that out. And now it is time for our Q&A. So let me jump back to the chat here and let's see what questions we have. So let's see here. So yeah, we've got that fun discussion about whether or not DNS is decentralized. It's one of the ways that I think about it. It is my mental model. I won't say this is any sort of official term from any standpoint. Is decentralization. True decentralization requires that you have no centralization. So like DNS is distributed, like lots of different computers across the globe are in charge. And there, you could say that there is a point of centralization, right? Because you've got those root keys for DNS. But you could also say that it's pretty centralized to that organization, right? Like you can't spin up your own independent DNS node and serve traffic from it. I mean, you can, and you can take complete control of that DNS node, but in order to serve real results, you're going to want to be part of that global hierarchy of registrars and DNS. So it's a little bit interesting. And yeah, Brian calls out that the overuse of the word is definitely something that happens. Question here. By putting crypto, blockchain, off-chain computations together, could you have an all-in record of someone's life? You could if you wanted to. I'd be worried about storage and transaction costs and gas costs, but this is actually something that I'm a personally big fan of. I believe in this thing called quantified self. And so I track tons of data about myself, from like every movie I watch to like I'm wearing 2 fitness trackers at almost all times. So I love this idea of having my own data and having control of that data and doing something with it. And so I think that the quantified self blockchain potential is huge, right? Because it has that built-in privacy, it's got that built-in security, where I could be building experiences and interfaces that expose just the data I want to people, and they could be interacting with me in just the way they want to, all transparently, all decentralized via the blockchain. And oracles are going to be huge, right? If you want to be integrating with data like from smart devices like watches and fitness trackers and all those sorts of things, you're going to need an oracle. And so Chainlink can definitely help you solve those very, very cool problems. So does it cost more gas if you use more require statements? I believe it does. So I could be wrong with this. So take it with a grain of salt, and I can double check this. But because those require statements have to execute on chain, basically every VM that executes the transaction has to verify and has to run that code. And so it theoretically should cost gas. One other thing I want to call out in terms of gas costs, and we'll jump back quickly to the code sample here, was a few different choices. So one of the distinctions you'll see between the contract that I've written here and the contract in Hardhat, that the code sample that I shared, is that I hard coded all of these directly in my contract. So in the contract that's in GitHub, you're going to see all those parameters being passed into the constructor. If you pass it in the constructor, it makes it easier to deploy across multiple networks, because like on Hardhat, you're going to want to be doing local development and Coven development and maybe like mainnet development. And so you're going to want to be switching these out. And so putting that in the constructor makes it a little bit easier. But I will call out that by doing it in the constructor, that actually adds a little bit of gas cost. Like I could actually make this immutable, which would save gas. And so creating a constructor that takes these and then assigns it to a storage variable is more expensive than just hard coding these things. So again, these are kind of minor gas optimizations, but if you're on something like Ethereum mainnet, this is maybe something you need to consider and think about. Thank you, Javier. The workshop is great. What are your thoughts about smart contracts being developed for Bitcoin? I think that the more smart contracts out there, the better. So effectively, if we want to usher in this new world that is more provably fair, you need blockchains, you need large scale adoption, you need decentralized networks. And if Bitcoin smart contracts become a thing and developers adopt it at scale, that could be huge, right? Because Bitcoin is clearly a huge thing. And if we can kind of combine both of those things, that might be a win. We've got another update from Tippy. Second deploy complete and confirmed a fake check upkeep. Awesome. So Tippy has been following along in this workshop and successfully run the fake check upkeep, which is great. One more tiny piece of advice I'll leave everyone with is if you ever do want to test the perform upkeep with some sort of data, let's imagine that maybe you're running multiple raffles. So you've got an array of raffles and you need an upkeep to determine which raffle is being checked on which timeline. You can pass in all of that here. I just pass in an empty array because that works. It's basically an empty bytes. But if you just put like 0x whatever encoded data, and there's lots and lots of like ABI encoder. By this one, yeah. So you can just put in whatever data you have here. And then it will encode it for you. I think there's an even easier one somewhere, but there's tons of these. So just give them a try, and then you can encode the data, and then it will be like 0x whatever, and then you'll pass in the data, and you can actually prove, or you can verify to yourself that the keeper execution is going to work the same as your tests. All right, we're at the top of the hour. Thank you so much, everyone, for watching. This has been fantastic. If you have any questions, feel free to shoot me a DM on Twitter, or just ask in the public, or on Discord, or on Stack Overflow. This hackathon is going really, really well from my perspective. And so thank you, everyone, for being a part of it. Have a wonderful rest of your day. Bye.